Yeah, so my name is Morgan Law. I'm an architect here in Colorado. I worked on the East Coast for about 5 years and certified, designed, and worked on a number of Passive House projects, both with the US body and the European body. There we go. All right. So yeah, I guess I got interested in Passive House. I went to the 2010 conference, and I was pretty blown away immediately by seeing builders, engineers, and architects all excited about the same thing, and generally holding hands and being excited about it. So that was a real question mark for me, because I hadn't seen that before. So I took the training, which I highly recommend for anybody who's interested, whether it's the European or the US. There's a wealth of knowledge of green building and green science in there that I think most of us didn't get in architecture school or anywhere else. So like I said, we'll look at some certified projects in other parts of the country, and that's our business name is Paper Airplane. So I'd love to give just a brief history of where this has all come from, and there's definitely a lot of people in this room that have been a part of that history and know it a lot better than I do. But yeah, so this whole movement that has really culminated in Europe and is now moving towards our country really began here in North America. President Nixon claiming that we'd be energy independent by 1980 was definitely a milestone, and kind of got a lot of interest going in this country and North America in general. This is basically one of the first Passive House prototypes from 1976. This guy's calling it the low-cal house. But it's got a lot of the same principles that the Germans adopted to the international standard and what we have now using in this country. Good access, super insulated walls, super insulated assemblies, really good windows, and mechanical ventilation. So all the same principles we'll take a look at. 1979, Jimmy Carter put solar panels on the roof of the White House. There's a lot of momentum. Builders know what they're doing. The magic boxes are starting to be created. A lot of the field testing has been done. Not to get too political, but this guy comes in, literally tears the solar panels off the White House, and we're kind of back at square one. So that's kind of, fast forward a few years, and the Germans basically took what was going on in North America and built upon it, and they directly reference a lot of the experimentation that happened, right here in the 70s and 80s, and basically refined it, right, and put their little German touch on it. And so, just to go over the standard real quick for people who are less familiar about it, there's FEIS, the U.S. governing body. There's 3 numbers to hit. It's climate specific, so that's the biggest difference, I think, between the two now. The international standard is obviously one standard, whether you're in Iceland or Ireland. But either way, there's 3 numbers to hit, right? It's not a point system like LEED. You either get it or you don't. That's the basic piece of it. So this is the first Passive House in Germany. Obviously reflects the building typology in Europe. A 3 or 4 unit townhome. So all of a sudden, things just get so much easier from a building science perspective, because you're going from a 6-sided box to a 4-sided box for some of those internal units. So really appropriate for the standard. First US certified Passive House, Katrin Klingenberg, who's the director of the US-based organization. Obviously, it reflects our own building typology in this country, the single family. So that's, I think, that we'll revisit that, but that's an interesting part of how these two movements began. This is the basic idea behind the Passive House movement, is that you're spending more money initially through increased airtightness, more insulation, fancy products, and eventually you break through this cost barrier, right? So your heating system drops down, and you have this amazingly performing house that's reasonably affordable, is the idea. The principles, have shifted a little bit from when people were doing this in this country in the 70s and 80s. Obviously, solar orientation is still important. Super insulation, the windows, airtightness, I'd say, is one of the biggest things that the Germans have kind of tapped into, and also the balanced heat recovery ventilation system. When we run our energy models, this is how we like to see our homes generating all their heat, right? So a third of it from people doing stuff, a third of it from the sun, and a third of it from your equipment. So when we run models, we actually like to see that broken down like that. So this kind of reflects the European standard, I would say, more than the new climate-specific US standards, but the idea is a 90% reduction in heating energy, and then a limit on overall energy use for everything, plug loads, equipment, HVAC equipment, all the pieces of the house, and then the extremely airtight construction, which is obviously measured in field, which I think is another reason why builders have really grasped onto this standard versus LEED and other things, is because it's very much dependent upon how they do their work and elevating their level of craft. So this gets a little technical, but I highlighted things, so I think it makes it a little bit better. So you can see the international standard hasn't budged. Their heating capacity is up there at the top, 4.75 kBTUs per square foot per year. If you look down at the US standard for Denver, we have a slightly higher threshold for heating, because it gets colder here than it does in Germany, where this standard originated. And our cooling is actually a lot lower because we have a really good climate that allows for thermal mass, diurnal temperature swing, all those type of things really help in that regard. The primary energy, so the total energy the house can use, is also different. In Germany and Europe, they count it on a per square foot or per meter basis, where the new US standards are actually per person, which I think is actually really appropriate for our country, because we're not Europeans. We use way more energy than Europeans. So that's actually become a lot more lenient to reflect the fact that, we're bigger, we're Americans, and so we need that difference. The air tightness is also different. So in Europe, it's a surface to volume ratio, which basically encourages bigger buildings, right? So the bigger building you have, the more volume you have, and the less surface you have. So in Europe, they encourage us, they're like, okay, if we encourage big buildings, then there'll be more townhomes and less single family homes. Really smart. It kind of had the reverse effect here, because we build single family homes, and so we're encouraged, you actually get dinged on smaller homes based on this air tightness measurement. So that's another thing that US has kind of addressed is it's more on cubic feet. So you don't get penalized for that smaller house now, which again is appropriate for us because we kind of messed that part up. This is the idea, right? So technically speaking, you can heat your house with a hairdryer if it's a Passive House certified project. You build a bigger house, you still slightly more heat in there, but again, these loads are tiny. Your heating system is tiny. So I'm just going to go through a couple assemblies real quick of the ones that I've seen a lot of on the East Coast, and I hope to see more of here. This is a great wall system. Is basically just a stud wall that's framed, and then they're putting SIPS panels on the outside of the stud wall. So they're not using them as structure like you think of SIPs being. They're just these big foam sandwiches that are attached to the outside of a wood framed wall. So it's a great application for these SIPS panels. And I'm just going to go through these a little quick. We can always talk about them afterwards. This is another really robust wall system. This is just a 2x4 stud wall. And then these TJIs are hung on the outside, and the whole thing is filled with cellulose. So very little global warming potential, very low embodied energy. Builders can wrap their heads around it because it's still a 2x4 wall with a crazy thing extending on the outside of it. But at least it's comprehensible in that regard. So this is another really good wall system, and we can geek out on it more if you guys have questions about it. But this is just an exterior rigid foam application. Again, there's all sorts of issues with rigid foam and their global warming potential. But you can get recycled foam, which I'll show you a project down the road here in a minute about that. But also a robust wall, eliminates thermal bridges. This is the double stud wall, which is very common in New England for doing passive houses. Totally thermal bridge free. You can see that whole cavity is just filled with insulation. And there's people in Alaska building these things where I've seen photos of like builders where their kids are like running through the walls because they're so big, and the whole thing is filled with cellulose. So this also is builder friendly, I think, because you're basically framing the house twice. There's some thermal bridges issues with this system, what we'll talk about. So this is another obviously huge principle of the passive house is the thermal bridge, right? So I know most of you guys probably have heard that term or even know what it is or have seen it, but that's the basic idea is when you have things going from inside to out, not only are you wicking that outdoor temperature in at an incredible rate, especially with steel, but you are also encouraging mold and other issues within the building assembly. So this, a couple really cool projects, right? But as you can see on these thermal images on some of these concrete cantilevers, that building is just heating the surrounding Chicago area in winter, right? So it's insane. All those slabs just go inside from out, and that mass is just wicking away whatever that interior heat is however that heat is being produced. So Passive House has a threshold of a thermal bridge, what thermal bridge free means, which is a tiny number, 0.0058 BTUs. What does that mean? The conductance of steel is at 29 BTUs, which is 5,000 times the Passive House limit. So there's no level of insulation. As soon as you put a steel beam on your house going from inside to out, like you're never going to recover from that. So that's a huge piece of this design, of these design tools that they monitor and help you with. And it's typically not as blatant as something running inside and out, but they happen and they need to be addressed. So the thermal bridge-free construction goes all the way down to the assemblies, every part of the building unit. Ideally, there's even thermal bridge-free windows. This one has a cork composite kind of running through the middle of the window, helping to create that barrier from inside to outside and the break. Airtightness is obviously another huge piece of this. That's another thing that happens, like I said, on site that is very hard to monitor and very frustrating at times. Because typically you're working with subcontractors that don't care about your passive house vision, and are in there and make a mess and get out of there. So this is actually a sign that this company provides to just plaster all over your job site, which who knows if that helps. But this is a product from Europe, zero VOC, made in a zero VOC plant. It acts as a vapor barrier and an air barrier. It's becoming a lot more common in this country. This is obviously on the inside of a cathedral ceiling, and then you see that strapping there for a cavity to run electrical lines. So pretty smart system, pretty amazing product.
What are we looking at? I'm not sure.
Oh, sorry. You're basically like in an attic and you're seeing the underside of a...
Yes, but what's the material you're talking about?
Oh, well, there's a couple different ones. This one's called Intello. There's Sega makes various air vapor membranes as well.
So it's a membrane.
It's a membrane and an air barrier. So yeah, it's different than the old vapor barriers that we stuck in our walls in this country that trapped moisture. These products are pretty amazing in the fact that it's not allowing any air infiltration into the assembly, but it's also allowing it to breathe when moisture gets in there. So pretty cool stuff. Reasonably priced. Then comes the air blower door tests, and the builders get to geek out. They get to walk around with these little cool smoke pencils and sniff out the problems in their assemblies, because the levels of air tightness that these projects are going for require this level of detail, and it's definitely a learning curve for everybody. This system on top, this Advantech sheathing, starting to see more of this where it's actually all the seams are taped on the structural sheathing. It's impregnated with a weather membrane on the surface of it. It's a pretty good product. Obviously, most people know this, I think, but spray foam is not an air barrier. It off-gases. It's not installed properly. It's terrible for the environment. You'll never, ever get it back in terms of global warming potential, the energy you'll save in your house versus what you're doing to the environment by installing this stuff. So, we really try to stay away from this. This is a boring graph about payback of various installations. We'll just kind of skip over that one. A huge piece of this passive house puzzle is the mechanical ventilation, which again, is shocking that there's so little of this in this country where it's very, very standard in most parts of Europe. It basically acts like a bunch of straws, and it's continuously drawing this fresh air in from outside and pre-warming it with the stale air that's inside the house. So these things are like 80 to 90% efficient. So if it's 0 degrees outside, 70 degrees inside, all of a sudden you have fresh conditioned air coming in at 55, 60 degrees. Pretty amazing. Obviously, it's a lot easier to heat up that air from that level than taking it all the way from 0. So, and we just rely on crappy construction for fresh air in our houses, at least in my house. So yeah, we've installed some of these, and I'll show you some in some projects. But then, of course, there's the total source energy. That's another piece. Again, there's the European standard down there based on a square foot. This one's really hard to hit for single family, for multifamily, for a lot of different reasons. It's hard to model. You guys have probably heard the expression, there's no net zero buildings, only net zero people. So a lot of this is like a question mark, right? About like what equipment people use, how often they use it, that sort of thing. So easy to type into an energy model, hard to get people to follow that. So again, that's why it was dressed by the US. This is a couple different modeling programs that are used. I'll answer questions about that, but it's not very exciting. So I'll just go through a couple of precedents. This is a single family home that I worked on as part of the design team and certified. This is a dashboard that we built on the front of the Passive House spreadsheet model. And it's basically a tool for clients that we've used. And if anyone ever wants this spreadsheet, this dashboard, I'll be happy to share it. It's really helpful because it is like a 30-page spreadsheet, but it all kind of comes to this front, and you can quickly dive in and change the different R values and all the different assemblies. And you can kind of see there's that 33, 33, 33 heat gain model that I was talking about. So this is a double stud wall project in Virginia based on the European standard before FIAS brought out the climate specific. So typically what we do with clients, we try to figure out various ways of getting to the Passive House standard, various assemblies, different ways of going about it. We try to find the cheapest way. We also run energy scenarios based on, different fuel options. In Maine, where I worked for 5 years, there's a lot different fuel options than there are out here. So we end up running a number of scenarios. So this is the project. This is the vapor barrier that's being installed underneath the slab. You can see all the seams being taped. And obviously this is gonna help mitigate moisture coming up through the slab. So the insulation is sitting below that, and the insulation is allowed to basically get wet and get dry. So again, like I said, this is the double stud wall, which is a good system. However, as soon as you get up to the rim area, as soon as you start stacking floors, you end up with these kind of awkward areas where there could be a thermal bridge. So you start introducing foam, and it's not ideal. So it definitely, you start cantilevering, framing out a little bit. It gets a little messy that way, but again, still a solid wall assembly. This is the project. I think that the cool thing about the Passive House standard is that it differs in the passive solar from the 70s, in that you really can build these houses to blend in with their the surrounding vernacular. You would never really guess that this is the south side of this Passive House. Granted, it's Virginia, but this is one of the biggest certified projects in the country. It's a 24-unit transitionary housing in Pittsburgh. I think these are the types of projects that the standard was meant for, that we should be seeing in Denver very soon, hopefully. This is an exterior rigid building, that kind of this thing that we looked at before. I was just the consultant and the certifier on this, so I can't answer any design questions, but a number of different wall assemblies that all have to be modeled differently. Pretty simple, straightforward building. just like I said, the rigid foam on the outside of a wood-framed wall. You can see actually down at this footing, there's a big old thermal bridge there, right? That concrete footing is just like sitting in the dirt. So we had to run some therm calculations on that, which, I think based on the size of the building, it actually wasn't a huge impact on that, and it was below their threshold, but that barely skirted through. Typically something like that would be more of a red flag, but I think, again, because of the size of the building, the fact that it was multifamily, it worked. Again, this is part of the energy analysis for internal gains, in equipment, and it's totally insane. You're like guessing at we had to put some of the lights on occupancy sensors that would go off every 2 minutes just to hit the standard. Again, this was done under FIAS before they had the climate specific, which I think is part of the problem, is that we were barely getting the overall energy use, and I'm sure that building is actually using more energy. But again, a lot of thought went into how to reduce those internal loads and the lighting and all that stuff. So it might not be hitting it, but I'm confident that it's close. So again, I was bored and I threw this project in. This is the one we just looked at. You can see the R values of the various assemblies, and you can see where we're at in terms of the heating and cooling. So we're getting pretty close to our threshold up there. And I just I basically switched over to Denver climate data to see what that project would look like if we'd built it in Denver. Obviously the heating goes way down, right? So we're still at the same assemblies, but all of a sudden we can really dial back some of those insulation values. If you start talking about the FIAS climate specific, all of a sudden we're going up to 5 instead of 4.75. So I basically just typed in this R25 wall. We're still hitting the standard, and that's right in line with the next code rendition that Denver is adopting. So what am I trying to say with that? It's not that hard to hit this standard, especially with this building typology. But again, there's a lot of other parts that go into this in terms of air sealing, good components, heat recovery ventilator, good windows. But it's not insane. We're not talking about like R50 walls. This is a school that I designed and certified in Maine. It's a PHI, so it went through the European governing body. It's another exterior rigid insulation building. So one of the first things we do, we like to make really dumb models in SketchUp and make sure we are figuring all the sides of the building and calculating those areas. That's a big part of this. Another big part is obviously shading. So this is our site. You can see to the south are these massive trees. Obviously the school doesn't want to start mowing down trees everywhere. So that was a really contentious issue of trying to be certified, but being very careful on how much trees we actually removed from the site. This is a Solar Pathfinder. This is a fantastic tool. It's been around for a long time, but basically what it does is you can see the various months of the year starting down below with August and April, September, March. So up here is January, February, December. And so as you go up in the cold part of the year, all the solar radiation is happening in the middle part of the day. So we were basically able, using this tool from, I don't even know how old it is, but we could literally pinpoint trees and just remove like a handful of them to make sure we were hitting our radiation points for the middle of the winter. So super cool tool, very, very dumb and basic, but very, very good to use. The mechanical layout, obviously as an architect, you get way more involved with that, and just finding space for all these new components it's definitely a stretch and something that has to be considered early. Looking at different types and brands is super important. This is just kind of an idea of what the building envelope looks like. Pretty straightforward assembly. Triple glazed windows, 4 inches of polyiso, brand new polyiso on the outside. So definitely a big carbon footprint on that one, but that was the most cost-effective way of achieving certification with this project. This is a 45-unit building in Portland, Maine. That's pre-certified through FIAS. It's basically almost built now. So it's modular construction. All these boxes get made in the winter, and there's various levels of doing modular construction. Obviously, this one is very basic, right? No finishes, no nothing, no insulation. It's a double stud wall. I think it's a 2x6 on the outside and 2x4 on the inside, a 10 or 12-inch wall, and literally just stacked. This is a low-income housing project, $145 a square foot for this project. So basic idea of the floor plan: commercial downstairs, single bedroom and 2 bedrooms on the upper floors. This is the outside. So it's being covered in a liquid applied air barrier, which I think is way more common on these bigger buildings. It becomes way more cost effective. So instead of like that sheathing I showed you guys with the taped seams and everything else, like this all of a sudden becomes very cost effective with this scale of building. And you can see all the windows have been taped in. And so, and even on the other side, you can see that first round of air sealing that happened where all the seams were and all the nail holes. So that's round 1. And then round 2, you get the full coating on this building. So extremely airtight. Here you can just get an idea of the windows. And again, that double stud wall that's going on each box. There's obviously some details that need to be thought about. This is like a thermal isolator for a structural column. So these are the types of things that make or break certification. So extremely important to think about. And I'm sure this guy's not too happy about that. But again, just huge learning curve from the subs on this project. A lot of them weren't very happy with it. But, again, these projects have to happen because they get so much easier the next time. This is just a recent project my company did. It's not certified, nor is it that close to being certified. A lot of it is because of our site. If we were in the southern hemisphere, this would be the dream site. You have big deciduous trees to the north and a building directly to the south about 3 feet away. So very early on, we just determined that it wasn't a great candidate for certification. But at the same time, we wanted to adopt a lot of the principles in the standard. So this is the existing house. It was actually a crack house with some scary stuff inside. But you can see they had some passive solar going on in the original structure. So this is the basement. There's all this reclaimed rigid foam that we were able to find. There's this great place outside of Denver called Reclaimed Materials, and they just get like truckloads of this foam that they pull out of old Walmarts, and it's kind of a pain in the ass to get, but you're basically creating a global warming potential of 0, right? Because somebody already made the bad decision to make this stuff. So definitely recommend that place. So a lot of this is reclaimed. This is the vapor barrier going on underneath. This is just like an interior shot of the frame wall, but you can see the cathedral ceiling, and so all those bays get filled up with cellulose. This is the south side I was talking about. Obviously, only a few opportunities here to do any sort of passive solar. Again, there's the outside rigid insulation, so a lot of that was reclaimed as well. This is the basement, so we have 4 inches of EPS foam on the outside of the foundation wall, so we kind of left the interior pretty raw, and that's the slab is just exposed with some stain on it. This is the inside of the house. You can see the mini split unit off to the right hand side. So there's 3 mini splits, 1 on each floor. They're just point source. So there is ducting in this house, but it's just for ventilation. So the idea is that the ventilation system essentially gets it up to a certain point, and then these things take care of the rest. The ventilation system also helps move that warmer or cooler air around the house. Yeah.
What size mini splits? Each floor
Yeah.
needed less on the top. Can you throw numbers just to make that?
I think they were 9,000 BTUs.
Each?
Yeah,
So
each.
you didn't stagger them?
No, we didn't stagger them.
Top of the 12 and bottom of 9 in the middle because you needed more.
Yeah. They're all basically the same because we figured that there would be good circulation with the mechanical ventilation. There's also backup heaters in the bedrooms upstairs, so that are strategically located basically right above the ventilation grates. So as soon as that air comes out into the room, like fresh, constant air, you can just kick up these little heaters, in the middle of the winter. Because again, people close their doors with bedrooms, right? There's not, down here in this open space, it's gonna have no problem
The
circulating.
backups are just resistance,
Just resistance,
so
just,
you're not getting the energy efficiency of the mini splits on those, right?
right, on the backups, yeah. Once those go on, it's super inefficient, but the time that I've spent in this house, like I really don't think they're gonna be needed that much. But again, it's really person-driven, owner-driven. We did actually get a couple like south-facing clear stories off to the right-hand side. You can see these little cuts that we tried to make in the building. There's also south-facing skylights, which is kind of a crazy move in Colorado. But again, we have so little fenestration on the south side and it's only in this double height space. So our thought was that it wouldn't be cooking in someone's bedroom necessarily. It'll dissipate through the house. This picture, you can kind of see this, this big beam up in the top portion of the slide. We try to incorporate these details where we're bringing a lot of the structural members inside the insulation blanket. So as opposed to bumping that up into the roof framing and creating one big thermal bridge, you drop it underneath and you get a nice continuous blanket above that. So that's the outside. That's the cool deck. Certification, I think that's extremely important, whether it's through the US or the European body. I've seen these projects like take off in New York and New England, and it doesn't take much. It's usually just like a couple certified projects, and then there's a lot of interest around this stuff. So I really hope to see a couple more certified projects in this area. And I think it's bound to happen. I just hope it happens sooner rather than later. With the international, I've found that I've handed it off to them a lot quicker because it's metric and confusing and there's language barriers. But there's also a great level of detail and care taken. This is just a back and forth between the US body that I've done for various projects. And I mean, they have some of the best building scientists in the country working for them. So again, saying that someone will build you a passive house is very different than having FIAS or PHI actually certify your project, because they really dial down on all these things that, if you hire a designer to do or a builder, they're not going to cross all these T's and dot the I's.
Who was they?
Sorry, this is the US body, FIAS. That's their kind of way of tracking all these changes in a project, but like I said, it's a little bit more hands-on with them. Which can be good and bad.
Question.
Yeah.
You say certified question mark, and you said it's very important. Okay, there's a value judgment. I want to understand why the certification is very important.
Right.
To the homeowner, or to climate, or to flood it out and Bangladeshis.
Right. The whole spectrum. I think it's extremely important for the client because there's so many people out there doing eco, green, passive solar crap that if it's not certified, it's not guaranteed to a certain level of thermal comfort, good air quality, lower energy use, resiliency over time. So I think there's plenty of incentives for the owner. For us, it's kind of the same argument for the Bangladeshis, if these buildings actually aren't achieving those metrics that we set out to do, what's the point, right? I mean, yeah, maybe they perform better, but it's hard to quantify. Yeah.
So you have an assumption when you say for the owner, that the owner is not an informed person that can do the judgment on what's good.
No, I'm not saying that they're not informed. I'm just saying that without it actually becoming certified, things can get missed, and it's that third party level of qualification that's the only guarantee, I think, to get it. Yep.
How much does it typically cost to get a house certified?
That's a good question. The things that you are looking at paying for is the actual certification through FIAS, which let's just say FIAS because I have a better idea of their pricing. It's based on a per square foot, so you can look that up on their website. I think it's about $1,000 for them, and which is totally worth it because they check everything. Then you have to pay somebody to do the PHPP model. A lot of clients or builders can do that, or architects. That's certainly something that people can take on, especially if they've done the training. And again, you don't have to get it perfect. You just have to get it underway so you can pass it off to the governing body. The air testing, so at least with FIAS, you need a third-party certifier who will come and do 3 blower door tests in different sequences of the construction. So that can range, I want to say, about $2,500. So it's definitely extra money. And that project I just showed you is a spec home. And again, we had a lot of things against us with the site, but we didn't certify it, nor could it have been certified. But yeah, I mean, I think that not everyone's going to certify. So the more that we can do, that people that care about good quality building and design and construction and the planet, I think anything we can do to get more projects out there. Like I said, I've seen in other parts of the country, as soon as there are certified projects that people can go and experience and feel how comfortable they are and, experience the air quality, then that's really what drives more interest and more, more momentum behind it. So, that's kind of, we just kind of talked about what I was going to talk about. Again, I think the construction methodologies are getting better, so airtightness is getting better, which is kind of a problem for us unless we address this more on a holistic level. The mechanical ventilation part, the heat recovery ventilator part of this is a huge way of dealing with this. In Europe, the standard, the kind of like golden ticket is that that little box, the heat recovery ventilator, is so efficient, it's your only heating system. So there's hundreds of thousands of projects probably in Europe where the only heating system is that magic box, which is doing a lot for a building versus, kind of the norm here. So I think there's a lot of potential there.
You mentioned heat recovery ventilator without talking about energy recovery ventilators.
Yep.
And is there a reason that you are particularly just saying heat recovery rather than energy recovery? They're different, but I just say that because it's kind of, that's the umbrella term. It's the one that's more common that you hear of. But yes, the energy recovery ventilator is different, and it's totally dependent on occupancy and the size of the project. So yeah, we've used both, but I just, I say HRV because otherwise, if I start throwing both of them back in there, then it's confusing. But yeah, that's a good point. So it really depends on the project. I think there's a piece of this design that's the rigorousness of the Passive House design is just puts more emphasis on the built environment. And you can see that across Europe with the adoption of not only that standard, but also the craft and care that goes into their building envelopes and their architecture. And I think this standard would go a long way to addressing some of our more recent issues in this city. We kind of talked about this with the Bangladeshis, but even in this country, you guys know all this stuff, so I'm not going to dwell on it, but this is obviously a big part of like why I'm interested in it and why I want to see more projects in this area, because this climate is perfect for it, and there's no reason that we should not be doing it. So again, the PHI chapter is up there if you're interested. The FIAS board, which is the US board. Passive House Academy is basically a third party that helps certify projects. They work directly with PHI, which is the all-knowing international body. So that's it. Thanks.
Question.
Yeah.
About 15